I'm masahikoItoh from Hokkaido Information University, Japan. Today, I'd like to introduce visualization system for analyzing the characteristics of areas with frequent water-related accident in river. This work is based on my previous graduated student, Momoka Aizawa's work. So first, background. In Japan, there are lots of rivers because Japan is a very mountainous country and it rains a lot. The number of water-related accidents in river in Japan is over 500 in 2026, and over 200 people were dead or missing. And there are 203 river water accident victims in 2026. It's over 35.7% of all water-related accidents. And the number of accidents has remained unchanged for over 20 years. So the purpose of this research, we want to try identify high accident areas in river and want to propose a visualization system for analyzing surrounding area characteristics. Related work. There are some research about visualization system to identify traffic accident hotspots. This work, it detected dangerous intersections for driving, but they did not provide mechanism for analyzing the factors that caused accidents. And there are many individual analysis of river accident causes. They investigate each spot include many accidents manually, but there are no research on a visualization system for extracting hotspots of water-related accident from big data and system for analyzing accident factors by exploring relationship with hotspot and the surrounding environment. So we propose a system for automatically extracting high water accident area from big data and for analyzing area with surrounding environment data. First, I'll introduce data set of water-related accidents in river and how to extract hotspots from these data. We extract data set from National Water Accident Map provided by the River Foundation in Japan. It includes over 3,000 accidents in river, lakes, and marshes from 2006 to 2023, maybe 24. And it consists of many attributes, such as date of accident, and latitude and longitude, and accident summary. To extract hotspots from these data set, we use DB-scan. DB-scan is a density-based clustering method, and we treat clusters that have we extract clusters that have 2 or more water accidents within about 0.5 kilometers by setting parameters of Davis scan. And then we manually observing the result of Davis scan to find out the characteristics of hotspot and surrounding environment. We find out there are many ridges around the hotspot and campgrounds and parks, and sometimes there is river islands. And rivers are sometimes very winding, twisting, and we are not sure population is high or low around the hotspot. So at first, in this research, we use the information about bridges, campground, and population data to investigate the relationships with hotspot and surrounding environment. So for this purpose, we collect the data set of population and bridges and campgrounds. To collect these data, we utilize Google Maps API. And we extract the number of bridges and campgrounds within 1 kilometer from hotspots. And we also calculated the distance to the nearest bridge and campground from the hotspots. And also we collect the estimated population data by 1 kilometer mesh in Japan from this site in Japanese. And we extract population around the hotspot. Okay. Then next, I will introduce our interactive visual analytics system. In this system, we use parallel coordinate plots for dynamic query. We can filter out clusters by using PCP. In PCP, clusters, each line represents cluster, okay? Each line represents cluster, hotspot. And there are 6 axes. First one is number of accident and population and the number of bridges within 1 kilometer and distance to nearest bridge, number of campground within 1 kilometer, and the distance to nearest campground. After we select clusters by using PCP, the result clusters are displayed on the map. In this map, the size of the circle represents the number of accidents in the selected clusters. And we can select the circle. Circle means cluster. And the detailed information about the selected cluster are displayed in the map or the data table. So I'll show some case studies. First one, we select clusters with at least 1 bridge and at least 1 campground within 1 kilometer. I'll show the demonstration. First, I select bridge and campground. Then results are displayed on the map. There are many hotspots. And these 2 clusters is very large. This cluster includes 13 accidents, and this one includes 14 accidents. And I select this one, and river is very twisted and many accidents. I can check the detail of accident on the tooltip, and we can check the detail summary here. And yeah, barbecue and diving and okay, diving after barbecue. Many. So diving from rocky area, jumping from a bridge, jumped from rocky place. Fire, no. Barbecue, after barbecue, drinking, after drinking. Anyway, next one is similar. River is twisted and there are many accidents. And yes, drinking, after drinking at a barbecue. And diving from rocky area after barbecue. And drinking at barbecue, diving from rocky, diving from rocks. Yes. Anyway, river is twisted, jump from bridge, barbecue, drinking. It's similar. So next example, we select the number of accidents over 5, population is under 1,000, and the distance to nearest bridge is under 0.2 kilometer. Okay. 5/5, low population, and near to the bridge. So we can select some clusters, and this one is the biggest cluster. It includes over 30 accidents. And here is a very famous spot, very dangerous place. And okay, fishing, yes, jumping off bridge, diving from bridge, sinking bridge, sink, yes, and jump off bridge, diving from bridge. So final one, okay. Last one is we select the number of accidents over 10, like this. Then each cluster shows a small population. That means many people come from other area to the countryside and have accidents. Anyway, the summary of result characteristics of hotspot. River shapes are curved, high accident, low population area, and many people diving on bridge, and barbecue and alcohol consumption led to water accident near river. So future work. So I want to observe relationships with many other features, such as river islands, number of river islands, or shapes of river, gradient of river, and parks. Are there any parks or not, and so on. And we want to construct a system for expandable. We want to construct expandable framework for users to add their interesting such feature data set. And I also want to do risk area estimation in rivers using these such features. There are many similar work on risk area estimation, such as estimating safety road or safety urban area, and like this. That's all. Thank you.